It's Mr. Wright. Today we're going to talk about the perpendicular bisector theorem and the angle bisector theorem. So this states if a point on the perpendicular bisector is on the perpendicular bisector of a segment, then it is equidistant from the endpoint of the segment. So this line is my perpendicular bisector. It is perpendicular to this line, and it splits this line in half. So this says that if there's a point somewhere on that vertical line on the perpendicular bisector, then these two pieces have to be equal. So that is your perpendicular bisector theorem. Let's see how we can apply it. So with this, I notice that I have a perpendicular bisector because both sides are 11, and I see the perpendicular symbol. So that means that this side has to be equal to this side. So all I have to do is set those equal, solve it, and then if I want to figure out AD after I solve for X, I just plug it into this expression. So that's how you set it up. So the big idea is just understanding how to understand like what's going to be congruent so you can set up the equation. And then you should be able to solve that equation for X. Here's another example. So this would be the converse of the perpendicular bisector theorem. So if you have that perpendicular line in the middle, and if these two sides are congruent, then that's going to mean that this is going to be congruent to this. So this is just like the converse. So you just write your equation, 5n minus 2 equals 2n plus 7. Solve for your missing variable, n, then plug it back in. So like this one, we're solving for wy. So after you solve for n, you plug it in there. What's the value of OL? So this next one, so OL, let's see. So first I notice that these are congruent. So if those are congruent, then this is going to be congruent to like that whole side. So if the left side's 14, the whole right side is 14. And then if I look at the small triangle, I notice that both sides are 9. So if both of those are the same, then these little sides are going to be the same. So if the whole thing's 14, each piece would be 7. So OL would be 7. So we were just applying the perpendicular bisector theorem twice for that problem. A couple more examples. Each of these is dealing with the perpendicular bisector. So RU is 16. If this is 16, SR is 16, and UT is 20. So let's kind of go through the thought process. If these are congruent, and I see my perpendicular symbol there, then that means that these two sides have to be congruent. So if that side's 20, this side's also 20. So then to figure out the perimeter, I just add up all those numbers and you get 72. But your thought process should be like, how do you figure out like that missing piece? Like how do you apply the perpendicular bisector theorem? Let's just look at one more. So SV is 38. SU, this entire distance is 26. The perimeter of SUV is 102. SUV is 102. So what we want to do first is solve for this missing side, UV. So in order to do that, if I know the perimeter is 102, I'm going to do 102 minus 38 minus 26. And that gives me 38. So that means that UV is going to be 38. So that tells me that these two sides are congruent. So because these are congruent and because I have this right angle, that means that these two sides also have to be congruent. So if the whole distance is 26, each half would be 13. So RU is what we're trying to find. That would be 13. So that's how we would apply the perpendicular bisector theorem. So there's one more theorem I want to go over. That's called the angle bisector theorem. So if a point is on the bisector of an angle, so first I know it's an angle bisector because I see these congruency marks in the angle. So AD is an angle bisector. So if we have a point on that angle bisector, so point D is on that angle bisector. So the distance to the two sides of the angle is going to be the same. So this distance, if it's perpendicular to this side, and if this distance is perpendicular to this side, then this has to be the same as that. That's your angle bisector theorem. So let's look at a couple examples. So if I look at this, I notice that this is an angle bisector because of these two marks. So that means that this has to be congruent to this. So in this example, if I know that they're congruent, that's how we set up the equation. You solve for x, and then if it wants to know what KL is, you just plug in x into that expression. So another one, hi is 7. So if this is 7, ij is 7. So if these two are congruent, this would be the converse of the perpendicular bisector theorem. If those pieces are congruent, if we're working backwards, that means that these two angles have to be congruent. Okay, so if HGI, if this is 25, then the other side also has to be 25. So that's what we're looking for. That side is 25. So the measure of IGJ is going to be 25. So we're just kind of working backwards. We're doing the converse to answer that question. Let's just do one more of these together. HGJ is 57. So this is saying that the whole thing is 57. IGJ is the bottom is 28.5. Okay, so what we want to do is figure out, is this line an angle bisector? So I need to figure out like what's the other half. So if I just subtract that, I get 28.5. So now I know that this middle line, that's an angle bisector. So if we have an angle bisector, then these two pieces have to be congruent. So if HI is 12.2, then IJ also has to be 12.2. So that's only true if that's an angle bisector though. So that's why you have to figure out that missing angle first. So that's how the perpendicular bisector and the angle bisector theorems work.